Hello, and thank you for watching this video about electric fields and interactions of charged particles. First, let's go over a couple of definitions. An electric force is an attractive or repulsive force between electric charges. Most objects and particles around us are neutral, but sometimes they have a positive or a negative charge due to too many or too few electrons. An electron is an extremely tiny particle with a negative charge. So an electric force is a force, which is a push or a pull, that is between objects or particles that are not neutral, so either positive or negative. An electric field is the area around a charged object or particle where other charged objects or particles would experience an electrical force, a push or a pull. This image shows what the electric field around a charged object might look like. The lines and arrows represent the direction that positively charged objects move, which is positive to negative. Now, keep in mind those lines that you see aren't actually there in real life. They are invisible. The electric field lines are drawn there to show the area around this charged object where another charged object would experience a push or pull when it got close enough. Different areas of an electric field have different levels of strength. The strongest area of an electric field is at its center, close to the charged object. Any charged objects in this strongest area would be highly affected, either with a strong push or a strong pull. However, the further and further you get from the center of an electric field, the weaker it is. Get far enough away and you'll be out of the electric field completely. Charged objects far from the center are less likely to be pushed or pulled, since the field is so much weaker. Charged objects interact with each other in unique ways depending on if the charges are opposite or the same. When charged particles are opposite, they attract one another or pull toward each other. Here we have two balls. The one on the left has a positive charge, and the one on the right has a negative charge. Opposite charges are attracted to one another. So if these charged balls are close enough to one another, they will attract each other and exert a pulling force on each other. If they are able to move, they will move toward each other. Here's an image showing the electric fields of oppositely charged objects when they are near each other. Their electric fields in the space between them have now essentially combined and show how any positively charged objects in this area would move toward the negatively charged object, following those available paths. If the charged particles have the same charge, it is a different story. Like charges, or charges that are the same, repel or push away from each other. So if we have two positively charged objects near each other, they will push away. If we have two negatively charged objects near each other, they will also push away. This is an image showing what the electric field lines might look like if two objects with the same charge were near each other. Notice how there are no field lines directly between them, like they're avoiding each other. Any positively charged objects in this area would move out and away.